Hello friends, myself Dr. Gunjan and I'll be taking your obs and gynae classes. As you can see, our today's topic of discussion is oogenesis. Now what is this oogenesis? The entire process of transformation of the primordial germ cells into mature ovum is called oogenesis. Now let us see, when does this begin? It begins in the intrauterine life. Mind you, this is in contrast to the spermatogenesis, which starts only at puberty. Now before beginning the process of oogenesis, I would like to discuss the two types of cell division with you. The first one is mitosis. In mitosis, there is cell multiplication, but the nuclear material remains as such. Whereas in meiosis, there is reduction of the nuclear material and multiplication of the cells occur. Now meiosis has got two parts, meiosis I and meiosis II. In meiosis I, the actual reduction division occurs, whereas in meiosis II, there is multiplication of the cells. Now this meiosis has got different phases: prophase, metaphase, anaphase, telophase and cytokinesis. Now this prophase has again got different stages. Now what are the stages? Leptotene, zygotene, pachytene, diplotene and dikinesis. Now with this basic knowledge, let us begin the process of oogenesis. So the primordial germ cells undergo rapid mitotic division to form oogonia, and since it is a mitotic division, the nuclear material remains as such, and that is 46XX. Now few of this oogonia, they enter the prophase of first meiotic division, and these are called primary oocyte. Here also the nuclear material remains as such, and it is 46XX. Now this primary oocyte, it gets arrested in the diplotene stage of the prophase of first meiotic division, and this is till puberty. So till puberty, the primary oocyte remains arrested in the diplotene stage of the prophase of first meiotic division, and this resting stage is also called dictyate stage. Dictyate stage. This is the resting stage at the end of the diplotene. Now this primary oocyte, it gets surrounded by granulosa cells present in the cortex and theca cells present in the medulla of the ovary. Granulosa cells in the cortex and theca cells in the medulla of the ovary. And this entire structure is called primordial follicle. So if this is a primary oocyte, it gets surrounded by the follicular cells, that is the granulosa cells and the theca cells, and this entire structure is called a primordial follicle. Now this primary oocyte, as we said, that till puberty it remains arrested in the diplotene stage of prophase. So what happens at puberty? At puberty, the hypothalamus gets activated. Now this hypothalamus, it releases a hormone GnRH, that is the gonadotropin releasing hormone, in a pulsatile fashion. Now this GnRH, it acts on the anterior pituitary and it leads to the release of two hormones, LH and FSH. About FSH we will talk later on. Now this LH, once it is released from the anterior pituitary, it starts to rise and ultimately there is LH surge, and this LH surge stimulates the meiosis I to resume and complete. So the primary oocytes, under the effect of LH surge, they complete the first meiotic division, and this leads to the formation of a secondary oocyte and the first polar body. As I said, it is a reduction division. Meiosis I is a reduction division, and so the nuclear material gets divided between the secondary oocyte and the first polar body as 23X and 23X. But here the cytoplasm, maximum of the cytoplasm comes with the secondary oocyte, and with the first polar body there is negligible amount of cytoplasm. Now this secondary oocyte enters meiosis II. but it remains arrested in the metaphase of the second meiotic division, or you can say metaphase 2. So this secondary oocyte, it remains arrested in metaphase 2 till fertilization occurs. Now it is this secondary oocyte which is released at the time of ovulation. As we said, that when there is LH surge, meiosis I resumes, the primary oocyte completes its first meiotic division, leads to the release of secondary oocyte and the first polar body, and this secondary oocyte is released out of the ovary, that is at the time of ovulation. Now the secondary oocyte which is arrested at the metaphase 2, this completes the second meiosis only at the time of fertilization. And after fertilization, it leads to the formation of a mature ovum and a second polar body. Now in this entire process of oogenesis, there are few important questions that you will be asked. And what are these? As I told you, that at the time of ovulation, what is the stage of the oocyte at which it is released? And it is the secondary oocyte which is released from the ovary at the time of ovulation. What is the stimulus for completion of the meiosis I or for ovulation to occur? And that stimulus is LH surge. And what is the time interval between LH surge and ovulation? It is 32 to 36 hours. Now this question can be framed differently, that when does meiosis I resume? It resumes 32 to 36 hours before ovulation. Because this LH surge, it causes meiosis I to resume and then occurs ovulation. As we told, at the time of ovulation, there is formation of one secondary oocyte and the first polar body. So the first polar body is formed when it is formed at the time of ovulation. And the second polar body, when is it released? It is released at the time of fertilization. Here it leads to the formation of female pronucleus or the ovum and the second polar body. Now, as we have already told, the oogenesis, when does it begin? It begins in the intrauterine life, and this is in contrast to the spermatogenesis, which begins only at the time of puberty. Now we'll talk about few measurements. Number 1, the size of the ova or the female pronucleus. It is 120 to 130 microns. Okay, 120 to 130 microns, and mind you, this is the largest cell in our body. Okay, the largest cell in our body is the female pronucleus. Now what is the size of the resting follicle? It is somewhere around 0.02 mm. At what size does the follicle ovulate? It is 18 to 20 mm. And one more very important question. What is the fertilizable span of the ova? For how long a ovum, when released, can be fertilized? And the answer is 12 to 24 hours. And here in contrast, I'll tell you that what is the time period for which a sperm can fertilize the ova, and that was 48 to 72 hours. Now few points regarding the timeline. When does what happen? So we'll start with the formation of germ cells from the epiblast. The germ cells, they are formed from the epiblast at 2 weeks of gestation, and these germ cells then migrate to the yolk sac, and this occurs at 3 weeks of gestation. After this, these germ cells, they have to migrate to their ultimate location, and that is the gonads. And this migration, although it starts at 4th week only, but this is completed by 6 weeks. So you can see the difference is of 3 weeks. So the germ cells reach the yolk sac at 3 weeks and they reach the gonads at 6 weeks. These germ cells, they undergo rapid mitotic division, and these lead to the formation of Oogonia. When does this happen? This is at 9 weeks of gestation. Again 3 weeks. Few of these Oogonia, they enter the prophase of first meiotic division, and they are called primary oocytes. And when does this happen? This is at 12 to 15 weeks of gestation, again a gap of 3 weeks. Now, these primary oocytes start being surrounded by the follicular cells, that is the granulosa cells from the cortex and the theca cells from the medulla, and it leads to the formation of the primordial follicle. So this formation of the primordial follicle, it starts at 15 to 20 weeks and it is completed by 22 to 24 weeks. Now we have some important questions regarding the number of follicles. Now what are they? The maximum number of follicles are present at 20 weeks of intrauterine life, that is 5 months of gestation. And what is that number? It is 6 to 7 millions. Now they undergo atresia, they degenerate, and at birth only 1 to 2 million of these follicles are present. At birth, I repeat it again, there are 2 million follicles. They keep on degenerating so that by puberty, only 4 to 5 lakhs of this follicle are left. And in the entire lifetime of female, around 400 to 500 of these follicles, they mature and rest degenerate. And what is the rate of this degeneration? Every month, around 1000 of these follicles are being degenerated. So with this, we come to an end of oogenesis. Thank you.